Hello, welcome to the Unit 3 study guide on decimals. Follow along so you can see how it solved these problems. So our first question says list these numbers in ascending order. Ascending means to go from lowest to highest or least to greatest. And our numbers are 3 and 85 hundredths, 2 hundredths, 3 thousandths, 3 tenths, and 34 hundredths. So I'm going to write these numbers down vertically, and I'm going to line up the decimal place so that I can compare the numbers. So the first thing we're doing, since we're looking for the smallest to the largest, we're going to see the ones that have, obviously the smallest value. And looking at this, I can tell that this one's going to be our largest because it has the 3 and the ones place, and the rest of them don't even have a ones place value used. So I know that's the largest one, and I'm going to put a 5 by that, meaning, 1 to 5, that's the largest. Now going down from there, I know that 34 hundredths is larger than this one because it has 34 and this one's only got 30. We can put a place value holder there. This is like 34 cents and this is 30 cents essentially. So I know that this one's going to be the fourth largest. This will be the third. Now we need to see which one's going to be our first and second, largest and smallest. So this one in money, we're talking about 2 cents here. And this one is no pennies yet, and is part of a penny. So we know that 2 pennies is more than no pennies at all. So this one's going to be our next largest, and then this one's going to be our smallest. This is 3 thousandths of a whole, and this is 2 hundredths of a whole. So that will be the order for number 1. Number 2 says write this number in word form. So basically, we don't have a problem reading our whole numbers. We know that that's 23. So I'm going to go ahead and write that down. 23. And we know that decimals are represented by using the and. And the next part, the tricky part people have a hard time, is how to read decimals. And so the way I would recommend is to read the number as it's given to you, so 84, and then whatever place value the largest digit, the last digit is in, that's the next word you say. So this one's in the the hundredths place value. So this is going to be 84 hundredths, because that's the hundredths place value, and don't forget the THS. If it were, say, this number right here, I would read the number 3, and then it's in the tenths place. I would read this one 3, but it's in the thousandths place. This is the tenths, hundredths, and thousandths. So our next one says compare these decimals using greater than, less than, or equal to. So again, we're comparing numbers, and I'm going to look at my first place value, the ones place, and they're equal. So I'm going to move to the next place, which is the tenths place. My tenths place is a 2 and a 2. Again, they're equal. And then our hundredths place is the 5 and a 5. Again, they're equal. And since the next place is the thousandths place is a 0, this one also has an understood 0 to be there. So it turns out that these two numbers are equal. Our next one looks like it didn't copy over, so I apologize on that problem. Actually, let me recall it. Hold on. Okay, sorry about that. So the problem should be 77 hundredths compared to 81 hundredths. So when looking at these two numbers, again, I'm looking at my ones place value. There's nothing there, so they're equal value. My next place value is the tenths place, and obviously 8 is larger than 7, so I know that 81 hundredths is larger than 77 hundredths. Another way in saying that is 81 cents is more money than 77 cents. So I'm going to place my symbol so that it reads that 77 hundredths is less than 81 hundredths. The next problem says to solve 20 and 31 hundredths minus 6 and 54 hundredths, subtract 5 and 43 hundredths divided by 2 and 6 tenths. So for the sake of time, I'm going to do a lot of just setting up the problem that I'm going to use my calculator to actually solve it, but I'm going to show you how it's lined up. So the first thing we need to do is solve in parentheses. We have our parentheses here, and we have a parentheses here. And we're just going to go up the first parentheses first, and I'm going to set up this problem. And when we're adding and subtracting decimals, remember we had to line up our place values, otherwise known as line up our decimals. So when I solve this problem, it's going to equal 13 and 77 hundredths. So I'm going to bring that down here as part of the problem. We must scratch work here, minus, and I'm going to set up this problem as well. So this one's going to be 5 and 43 hundredths divided by 2 and 6 tenths. Now, before I can divide, I need to make sure my divisor is a whole number, so I'm going to multiply by 10 for our divisor. And what you do to the divisor, you do the dividend. And when multiplying, I am able to move my decimal one place to the right for multiplying by 10. Do the same thing for my dividend. And so now my problem would stand as 26 and 54, and 3 tenths. And don't forget to bring your decimal to the top in the quotient and add on 2 more zeros for to have 3 places after the decimal, just as a recommendation for you. And when I do that, the answer equals 2 and 88 thousandths. Now again, I want you to divide this all the way out, but for the sake of time, I'm just leaving it right here. So now I'm going to bring the rest of my problem down. And now I've got this is my last thing to do, is subtract 13 and 77 hundredths minus 2 and 88 thousandths. So I'm going to go over here. And again, lining up your decimal place when you are subtracting and adding. Now in this problem, since there are no thousandths to take away, I'm going to go ahead and put a 0 there so I can know that that's understood to have it. And when I subtract this, I get 11, and I bring my decimal down, and 682 thousandths. So that ends up being our final answer. The next one is 6 and 18 thousandths, hundredths times 78 hundredths. So in setting up for multiplication problems, all we have to do is line up our digits just to make the multiplication easier. And this one so happens to be the decimals are lined up, but it doesn't have to be so. And once we get this set up, we multiply. My answer comes out to this once you add up all of your numbers. And then the tricky part is knowing where to move the decimal, because we don't bring it straight down. We figure out how many places after the decimal there is. There's 2 here, and there's 2 here, so a total of 4 places. So we come in our answer and move our place 4 to the left. So our answer is 12 and 6 thousand. There we go. Okay. So then that ends up being our final answer. So again, all we have to do is line up our digits on our multiplying and dividing, on our multiplying. Okay, so the next one, the problem, I couldn't get it copied over, so it looked like this on your paper. What you need to recognize is while it looks like a fraction, it basically means to divide 4 and 55 hundredths divided by 5 tenths. So again, I need to make my divisor a whole number, so I'm going to multiply by 10, thus moving the decimal over. And once we did the divisor, we did the dividend. So we move it over here and then move it up in our quotient. And when we do that, we find that our answer is 9 and 1/10. So 9 and 1/10 is our answer for number 7. Again, going through the division process, I'm just saving time on the calculations with using my calculator. The next one on your paper is 147 to the second power. This is what the computer looks like when you do second power. So if you remember from our exponent work, 1 and 47 hundredths to the second power is just like this. We write our number, whatever the base is, we write it the number of times it is indicated. And when we're doing multiplication with decimals, again, we're lining up our place value. Sorry, long day. Line up our digits. I apologize. And when we do that, our answer comes to this when we add up our values. And again, we have to find our decimal place. So we have 1, 2 places here, 3, 4. So 1, 2, 3, 4. So our final answer is 2.16. There we go. Okay, and that's our final answer for that problem. All right, number 9. Adding 45 hundredths plus 3 and 207 thousandths. So I'm going to take my largest place value up here and put that first, and I'm going to bring in my other number, and again we're lining up our decimal. When we do that, we bring our decimal straight down in our problem when we're adding and subtracting. And that's our final answer. All right, so don't let this one trick you. Whenever you see a whole number, know that, and especially dealing with money, our whole number can have, you can add a decimal to the end and add zeros for the number that you need to subtract. So for this one, we need 2 because we have 2 in the hundredths place value. So I'm going to line up my decimals right here, and then I go through my subtraction process. And when we do that, again, remembering with our subtraction problems that we bring down your decimals, bring it straight down, and we get $6.28. All right, getting into some word problems now. So taking your time on word problems, making sure you read them carefully and underline keywords, and then double check to make sure you've answered the question appropriately when you finish. So Tom has $84.50 and then spent $12.25 for a music CD, $17.85 for a gift, and $15.45 for a gasoline. How much did he have left? So there's a couple of ways you can solve this problem. I'm going to find out how much money he spent, and then I'm going to subtract it from how much money he had. So I'm going to take my 3 values that he spent, and I'm going to line them up. And when I do this, 5, 10, 15, 8, 9, 10, 11, 12, 13, 14, 15, 7, 8, 9, 10, and 5 is 15, and that's 45. And I'm going to bring down my decimal and we're adding. So far it appears that he has spent $45.55 if my math is correct. I'm going to then come over here to my how much money he had, $84.50, and subtract the money he spent, which was $45.50, 55 cents, I apologize. Okay, so 55 cents. So now I can subtract. I can't subtract here, so I've got to regroup and borrow from here. And now I've got 10 minus 5 is 5. I can't again, so I've got to borrow from here. And I'm adding 10 to this group, so 5 and 14 is 9. Bring my decimal down. Again, I can't subtract. Got to borrow again. 13 minus 5 is 8. And then 7 minus 4 is 3. So I've got $38.95 left is what my answer indicates. And I'm going to add that to my answer so I know that that's what it is. So over here is $45.55 is spent. And this is what he had left. So this is my final answer. Okay? All right, number 13. Nick has 42 and 2,500 meters of Hubba Bubba bubble tape. If he cuts it in 13 equal pieces, how long is each piece? So again, I've got 42 meters and 25 hundredths divided 13 ways. So 42 divided by 13 goes in there 3 times. And I'm going to go and pull my decimal up here so I don't forget that right now. Very important. So then 13 times 3 is 39. Subtract. And then I bring down my 2. 13 goes into 32 twice. 26. Sorry, I'm going slanted. And then 5. 13 goes into 65. Let's see. 5 times. And then 5 times. And it's actually perfect. So I don't need to add another 0 here because I've finished out here. So it looks like each piece is going to be 3 and 25 hundredths of a meter long. So each piece. So that would be our final answer. All right, number 14, Garrett can skateboard at a rate of 17 and 6/10 of a mile per hour. How many miles can he skate in 4.8 hours? So if he's skating and if he can do 17.6 miles per hour, then if I'm being asked how far can he go in 4.8 hours, that means I'm going to have to multiply. So I'm going to set up my problem by lining up my digits because I am multiplying. And 8 times 6 is 48, 56, 57, 8 times 8. And then I place value. So 4 times 6 is 24. 7 times 4 is 28, 29, 30. 4 times 1 is 4 times plus 3 is 7. So now I have to figure out where my decimal is going to be in our answer. And we have 1 place after the decimal here and 2 for this one counting total. So 1, 2. So I do the same thing in my answer. So my answer will be 84.48. Now let's go back in the problem and see what the unit's going to be. How many miles can he skate in 4.8 hours? So he's going to skate 84.48 miles. Number 15, the total ticket receipts for a play were $2,362.50. If the tickets were $4.50 each, how many tickets were sold? So this one's going to be taking a whole and making it into parts. That means we're going to be dividing. So we're going to set up the problem, 2362. That's driving me nuts, sorry. So again, when we're dividing, we have to make sure we have a whole number in our divisor. So to get this to be a whole number, we have to multiply by 100, and that moves our decimal 2 places to the right. Do the same thing in our dividend. So now our decimal is here, and I'm going to go and put it up in my quotient to make sure I don't make a mistake there. 450 cannot go into 2, cannot go into 23, cannot go into 236. It can go into 2,362, and it goes in there 5 times. So 5 times 450 is 2,250. Then I subtract, and I have 112 left over. I'm going to bring down my 5, and now I have to figure out how many times it will go into this number. And again, make sure when you're dividing and you're putting your quotient up here that you put it above the number you're dividing. So this digit is the 5, so I'm going to make sure my answer of 2 goes above that 5 and I don't lose that place value there. So 2 times 450 is 900. I have 225 left over. I'm bringing down my second zero, my next zero. And it looks like, because I remember from up here, I've already used that one, so I know that 450 goes into 2,250 5 times. And in doing that, we don't have any leftovers in this problem. So if we had leftovers, I would have wanted you to go 3 decimal places and keep on dividing so we can figure out, an estimate here. But since we landed on an even number, we're good to go by stopping. So I go back to our problem. It says how many tickets were sold. So the answer would be 525 tickets were sold. All right, number 16. iTunes sells songs for $1.29 a piece. How much money will Aiden need if he wants to buy 38 songs? So this is taking a piece and multiplying it by the number you want. So this is multiplying. So I'm going to go ahead and write down, and I'm going to line up my digits. So 8 times 9 is 72. 16 plus 7 is 23. 8 times 1 is 8, plus 2 is 10. Go to our next place value. 3 times 9 is 27. 3 times 2 is 6, plus 2 more is 8. And 3 times 1 is 3. So when looking back, it looks like I've made a mistake. Hold on 1 second. Oh, I forgot to carry my 1 here. I apologize. So this should be 7 plus 3 is 10. I didn't carry my 1 there. So I'm glad I checked that. So that's a 1. Oh, I did carry. I just put it on the other side. I'm sorry. Okay. So scratch that out. It's right there. Okay, so then our decimal place in multiplying, we count 2 decimal places here. There's none in this one. So we'll go over here. So it looks like we're going to need $49.02 to buy for, the 38 songs for Aiden. So Aiden needs a lot of money to buy a lot of songs. All right, next problem. Billy runs daily as part of an exercise plan. On Sunday, she ran 8.3 miles, on Monday, 5.1, and on Tuesday, 5.75, Wednesday, 5 and 6 tenths, and Thursday, 4 and 25 hundredths, and 6 miles on Saturday. It's a lot of running, right? How many miles did she run this week? So since there's a lot of values going on, I'm going to go through and 8.3 miles, or 8 and 3 tenths, 5 and 1 tenth, 5 and 75 hundredths, 5 and 6 tenths, 4 and 25 hundredths, and 6 miles. I'm going to go through and add them up separately so I don't make a mistake in my addition. I'm going to take my my hundredths ones and add those up together. So 5.7 miles and 4.25. I'm then going to take my 8.3, 8 and 3 tenths plus 5 and 1 tenth plus 5 and 6 tenths and add those up, and then I'm going to have my leftover 6 miles here. So I've got 1, 2, 3, 4, 5, 6 of them, so I'm good to go here. Bring my decimal down. So I've got 10 miles here. Got 19 here. So I need to add 10, 19, and 6. So it looks like I have 35 miles that she runs. All right, our last question. Melissa purchased $39.46 in groceries at a store.
The cashier gave her $1.46 and change from a $50 bill. Melissa gave the cashier an angry look. What did the cashier do wrong? So in looking at this question, I was first really confused. It's like if they know how to line up decimals, it shouldn't really be a problem. So when I wrote the problem down, as if I were going to solve it, I looked at it and I was like, what did she do? So in my thinking, I think that she got $1.46 because she just brought the 46 cents down. And then over here, she went to borrow, and I think when she borrowed, she got the dollar. I think she just mismanaged her borrowing with the zero. So I think that's where she got her $1.46 mistake from. And basically, on a test, if this were the question, everything that I'm saying you would need to be writing in paragraph form so that I can, read your thinking. But just to make sure, I'm going to go over here and solve it accurately because we know that is wrong. And I'm going to add in the 2 zeros this time so that it looks like I have something to subtract my 46 cents from. So I've got $50. I need to basically regroup my pennies and take a dollar and regroup that. So I'm going to take this away and make $49, and I'm going to replace this with 100 cents. So $49 and 100 cents is the same as $50. So this leaves us with 54 cents here. And then over here, we're left with $10. So she should have received $10.54 back, which is why she's angry, because she only got $1.46. I'd be angry too. But being able to prove the math and lining up your decimal places will surely help the cashier. I'm assuming she didn't have a register to help her subtract, so that's where that mistake came from. And that's it. So if you have any questions, come see me during homeroom or focus time, and we can see what we can do.